Right on to the second page, we are asked to find the length of the hypotenuse of these triangles by using both the Pythagorean theorem and the distance formula. And you'll notice that the distance formula here looks a little bit different than it did on the first page that I did. And we'll talk about how these are similar and different as we go through it. So let's call this side RA, let's call this side RB, and then the hypotenuse has to be the C. So the A is going to be 1, 2, 3, 4, 5, 6, 7 units. The B is going to be 1, 2, 3 units. And then that's equal to C squared. And so 49 plus 9 is equal to C squared. That's going to be 58 equals C squared. Square root of 58, square root of C squared. Square root of 58 is 7.62 is equal to C. Now the distance formula over there, the way that we've seen the distance formula so far looked like this. And the way that this formula that I'm highlighting yellow is different than the other formula is that basically the D is not squared in the formula that's highlighted yellow, because what happened is to get that, turn this thing, let's do that. To get that, someone said, hey, let's just take the square root of this whole thing over here and take the square root of D squared, and that will give us something that looks like this. Square root of x2 minus x1 squared plus y2 minus y1 squared equals D. To me, that one that's highlighted yellow, and so recognize the one that is blue that I just made and the one that's highlighted yellow are the same thing. To me, the one that is highlighted yellow is really kind of wacky. Like, that's a lot of stuff going on. So my personal preference is that when I use the distance formula, I'm going to use the one that has the D squared because it does not look quite as nasty to me. So I'm going to rewrite the distance formula here to be D squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And to do this, I'm going to go ahead and erase what I had on the triangle. We're just looking for the length of the hypotenuse. And so we're going to say, okay, that's the point, and that's the point that need to be connected to create the hypotenuse. And that's going to be at 8, 3. This other point is going to be at 1, 6. And then we're going to go ahead and label them. We'll call this x1, y1, x2, y2. And again, you could reverse the order of those. It's not going to matter which one is x1 and which one is x2. No one cares, as long as the 2's are together and the 1's are together. Now we just need to substitute those values in, and we're almost done when we do that. So D squared is equal to x2 is, oh, and I forgot, put your template together first, schlegel, because otherwise you're going to end up with a mess with negative signs. So always do the template. x2 minus x1 is going to be 8 minus 1. And y2 minus y1 is going to be 3 minus 6. And so we're going to get D squared is equal to 8 minus 1 is 7 squared. 3 minus 6 is negative 3 squared. And you see that that 3 is negative, which looks like it could pose a problem, but watch, it's not going to. D squared is equal to 49 plus negative 3 times negative 3 is 9. D squared is 58. Just like it was when we did the Pythagorean theorem. So square root of D squared is equal to the square root of 58. D is equal to 7.62. So again, the distance formula and the Pythagorean theorem are exactly the same thing, just with a little bit more going on when we do the distance formula. So Pythagorean theorem for this one, we'll have A, we'll have B. And our A value is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 squared. B value is 1, 2, 3, 4, 5, 6. 6 squared equals C squared. That's going to be 100 plus 36 equals C squared. And that's 136 is equal to C squared. Square root of 136, square root of C squared. Let's find the square root of 136. 11.66. Okay. Using the distance formula now. And I know the distance formula feels like more work, but it's actually less work when you have problems that don't already have a triangle there. Okay, so on to the distance formula, and again, I am going to use my version of the distance formula instead of that one. So I will have d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And then what we need to do is recognize we're trying to find the length of the hypotenuse. So from there to there, along that red line there. And our names of our points would be 6, -3, and -4, 3. Super important. Name these darn things. And just for giggles, I'm going to name this one x1 and y1. I'm going to name this one x2 and y2. If you choose to name these ones x1 and y1, you're going to get the exact same thing that I am. It does not matter which point you assign the number 1 to, or which point you assign the number 2 to, as long as they match. So the x1 and the y1 go together, the x2 and the y2 go together. Okay, coming down here, all we need to do is substitute. So d squared is equal to x2 for me is -4. Oops, and I forgot again. Schlegel, always put your template together before you start putting numbers in there. Otherwise, you're going to make a mistake. Schlegel. Okay. x2 is -4. x1 is 6. y2 is 3. y1 is -3. So see right here, this is where the problem happens if I don't put my template together. I often just accidentally put 3 minus 3 instead of 3 minus -3. So again, the template is super, super helpful. So we got to do a little bit of math here. So d squared is equal to -4 minus 6 is -10 squared plus 3 minus -3. I'm going to rewrite that as 3 plus 3. I'm going to take the time to do that every time because I don't want to make a silly mistake. So d squared is equal to -10 squared plus 3 plus 3 is 6 squared. So d squared is equal to -10 times -10 is 100. Positive 100 because a negative times a negative makes a positive. 6 times 6 is 36. So d squared is 136. Just like we had before, square root of d squared equals square root of 136. D is equal to 11.66. Exact same thing we got with the Pythagorean theorem. We just don't need a triangle to do it.